So we've talked about arithmetic and geometric series, but there are like the other series, because we keep saying like determine if the sequence is like arithmetic, geometric, or neither. And so this is like that other case where they don't like fit into one of the nice categories we have. So since these series are not going to be arithmetic or geometric, the one note to make, and I would maybe put this in bold or in caps or something big, we're going to say don't use a formula. This is the most common mistake that I see students make, is they try to use one of the formulas to find the sum, and you cannot, because these ones don't have a formula. So we're just going to look at a couple so you guys can see what you might be up against with these. So here's the first one. We're going to find the sum of this one from the third term to the 84th term, and you're like, oh my gosh, I can't use a formula on this. How am I going to do all of those? But the pattern here just says -7. There's no k. There's nothing to plug in. So what that means is you're going to say, okay, my third term is -7, my fourth term is -7, my fifth term is -7, my sixth term is -7, all the way up to my 84th term is -7. So as you can imagine, we just need to know how many terms we're finding, and then if we know how many terms we're finding, we can just take that number, multiply it by -7, and then we'll have it. So if you guys remember, to figure out how many terms are between here, we have to do 84, take away 3 plus 1, and so that's 82 terms. So I'm just going to do 82 times -7, and then I know that the sum of this series is -574. So just because we can't use a formula doesn't mean we can't find the sum in a smart way. So that was the first example. Here's another one. This one will be a little more tedious than the other one. We're going to start at the 5th term and go to the 9th term. And this time the pattern is going to be k squared plus k. Now you can be kind of tricky on these. I'm all about being tricky. So what I'm going to do is I'm going to type this in, and I'm not going to graph it. I'm just going to look at the table. So the 5th term is 30 and 42 and 56 and 72 and then 90. See, that's not so bad. The calculator found the terms for us. And then I'm just going to go ahead and add those all up. So again, when I do these, I can't use a formula. I have to be really careful to recognize that there's no formula I can use here. Now when students see this formula right here is almost a combination, like that part right there looks like it is geometric, and then having like to an I and a minus something kind of looks like it's arithmetic, and so students will see this and then they'll do one or the other. But again, this is a neither pattern, and so I'm going to go ahead and be lazy about this. I'm going to have 2 to the x, take away 3. I'm going to go ahead and look at my table. And so my numbers here, I've got more of them this time. 29, 61, 125, 253, 509, 1021, 2045. And when you add all of those up, it's 4043. See, not too bad. So really the hardest part, I think, is just remembering you can't force it to be one of the other types. Alright, so there's another way that we will work with the other types of series, and so we'll give you a pattern, and then we'll ask you to write it in the sigma or the summation notation. Remember, those are two different ways of saying the exact same thing. So let's say I gave you the pattern and I said 2/3 plus 3/4 plus 4/5 plus 5/6 plus and let's say I wanted you to write the sigma notation for it, we could say that if you're calling this one the first term, then the pattern would be on the top we have k plus 1, that's how we got to 2, and on the bottom we would have k plus 2. So if this is the first term, then over here to get 15 on the top we must have had 14 plus 1, so that means we're going to the 14th term. So that would be one way to write it. Or, and on these you usually have a couple different options. Another way we could write it is we could say, I'm just going to call this the second term, because it has a 2 on top. So then I would say k, and then over here this would be the 15th term. So it would be k over k plus 1. So it is not uncommon when you have like the other category that you could write the summation notation in a couple different ways. You just have to be really careful of what your start number and your end number are to make sure that you're writing it accurately. Alright, and then we're going to do one more, because sometimes they'll give you a problem like that, only there truly is just one correct way to write it, and I want you guys to be able to see the difference here. Okay, so summation notation. Now, if you look over here, they made it very clear. I guess you guys, if you can see, the tops are staying at 1, the bottoms are multiplying by 2. They're alternating signs, which means that our R value would be negative. And they made it so you had to write this a certain way because they showed you that they're leaving the 1 on the top. They're not calling R negative 1/2. They're writing 1 on the top and they're putting a number on the bottom. So we have to write it this way because they set it up to make us do that. So I'm going to say 1 over negative 2 to the k, or I, or whatever letter you guys want to use. So whenever they have it set up like this, that exponent is just what you're plugging something in for. And so I know that my last term is going to be the 12th term because that's what they were plugging k into. And then over here, I'm going to say that the starting term, for us to be able to make this equal 1, then that means that the k value here must have been 0, because if it truly was 1, then our first term would be that. And so we're not starting at the first term, really, we're starting at the 0 term. So you'd say k equals 0 right there. Now on this one, there is one other way that you could write this if you truly wanted to start at the first term. So I guess in this one, there's a little bit of variation, but not as much opportunity for variation as the other one. So we would have to keep the 1 on top, we have to keep the negative 2. So for us to be able to plug in a 1 to the exponent and still have the answer be 1, then our exponent here would have to be k minus 1, like that. And then that would mean that our last term would be 13 minus 1 to get that 12, and so we'd have a 13 right there. And it would be okay to write these because both of these would make sense if you had 1 over negative 2 to the 12th. Alright? So but you'll notice these are very similar as opposed to this one where these formulas look a lot different from each other. So just be really careful of that when you're looking at your final number, and be really careful to make sure that your first number truly does fit your pattern so you're starting at the right spot.